that what I think it is? It is. Look what I found. It's a nautilus shell. Isn't it beautiful? See that signature spiral? Well, I guess it isn't that special. It's in flowers and pine cones too. It follows this special pattern called the Fibonacci sequence. It's this pattern where you add the last two numbers and you get the next one. It was discovered by this famous mathematician, Leonardo Fibonacci, who lived about 1,000 years ago in Pisa, Italy. It follows the simple sequence. You add the last two numbers, you get the next one. So, for instance, zero plus 1 equals 1, 0 plus 1 equals 1, and 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, 3 plus 5 equals 8, 5 plus 8 equals 13, and as you can see, it makes this spiral, which will continue on forever. So, do you want to hear something really interesting? It's also in your finger. So, you have four bones in your finger. If you were to hold it up to some ruler of sort, you would find that the first bone would be 2 units, the second would be 3, the third would be 5, and the fourth would be 8. Oh, and your form's also proportional to the golden ratio. Wait, what's the golden ratio? Oh, I'm glad you asked. And what is this golden ratio? So it's also called phi, and represented by the Greek letter phi, and it's an irrational number. So you find it like this. So phi equals 1 plus 1 over phi, or phi squared plus phi plus 1, or phi equals the square root of phi plus 1. And from this formula, you find that the ratio is 1.618, so on. Golden ratio is the number that you get when you divide two adjacent Fibonacci numbers, and it will equal out to be about 1.618. So for instance, if you divide 8 by 13, you will find that it equals 1.625, which is about the same as 1.618, which is the golden ratio. I hope that answered your question. Oh well. Well, I hope that you found that interesting. At least I think that this idea or this topic is really awesome. Well, I should get going now. I want to add this shell to my collection. Bye. Wait a second. Is it snowing? Snow is amazing. Let's look at it with my magnifying glass. Whoa! This one looks like a conch snowflake, which is a type of fractal. Did you know that fractals are also kind of like the Fibonacci sequence? They're a visual expression of a repeating formula or pattern that starts out simple and gets more complex as it goes on, though they're much of a paradox. A 20th century mathematician named Bernard Malenbrat created the term fractal in 1975, though beforehand there was still no idea what fractals were and were everywhere just like today. Okay, now back to this awesome snowflake. This fractal snowflake is formed by taking a triangle and turning each third in the middle of each segment into a triangle bump in a way that makes it symmetric. Each bump is longer than the original segment, still containing fitting space within, like the golden ratio. Rather than staying on a single number, the perimeter continues on forever, coming closer to infinity. Wow, fractals really are extraordinary. It must be my lucky day. I got to experience some amazing science and math by just being outside. It's amazing how much great information you can learn, and best of all, it's super interesting, at least I think. I hope that you learned a lot from me and will continue to study more on this incredible topic, the Fibonacci sequence, the golden ratio, and fractals. Get outside and learn. I wish I could explore more, but I really should get going. It's starting to get a little chilly. Bye!